for YouTube. I'm going to drop the link. Sorry for my delay on that. All right, that ought to be going. Let me just get the, there we go, get the playable version here. And hang on a second. All right, that ought to be today. All right, so there's the link. Okay, Matthew, I think you got a hot mic. It's not really loud, a little clunking, like maybe a little tea or something. I don't know. Okay, all right, let's do the thing. Let's do it. So we actually started talking about this, and we got some of the Dr. K philosophical musings. It was tea. Matthew, I called it. Were you really? You're not just patronizing me. I literally said it sounded like you were like stirring your tea or something. That's okay. Yeah, I'm a freaking genius. Okay, so here's what we're doing. It sounds delish, by the way. I could use something over here. Oh crap. Okay, yeah. Tell me more about that. I got my, by the way, I got my #2 Moderna on coming up on Thursday, and I'm kind of expecting to be down Friday. I don't know. That's all. That's what I'm hearing. Is crazy bad sore arm. Was that the first one? Was that the first one, Matthew? Anyway, I'm just curious for if you wouldn't mind dropping that. I just for information, you know. But like I said, I got the first Moderna a month ago, and you have to wait a month. Then got the second one, which is coming up Thursday, and I booked it actually for Thursday, like right after this class, so I could duck over, come back, teach my other class, and then be okay to just kind of go out, you know, be down if I need to for a day or two. I don't know, right? What's going to happen?
So I got the Johnson & Johnson.
So the one
which
shot.
only needs the one shot.
Yeah.
Yeah. And I mean, it doesn't. It like you get the muscle cramps, but that's the same with any shot.
Yeah.
And like I just have a headache.
Oh man.
So it's not like I'm not functional. It's just that I'm less functional.
Yeah, I'm expected to go like decent fever is the classic for Moderna. So I don't know. We're gonna find out. I'm game though. Okay, so here's what we were talking about. Let's kind of hit it. Yeah. All right. Okay. We did this already, right? This notion about not just throwing up your hands. I beat the ever-loving crap out of this. Okay. And by the way, I hope, you know, as people are going back and reviewing, and I don't know, I'm probably not even talking to the right crowd, but I hope that people don't skip that speech, you know, because like that's not going to be on the test, you know, because some of that is really important philosophically, even if I'm not going to ask you a question about it, right? Not everything that's going to come into your life that's going to be valuable for your career is something that you can answer a multiple choice question on. You know, sometimes it's about this other experience. So I encourage you. I mean, I think there are classes where, let's be honest, the whole experience kind of begs you to dial out. I'm trying really hard not to be that one. Your mileage may vary. Okay, so what I want to do today is, by the way, if somebody can find this, this is a Dilbert clip. Now, the problem is that the audio on this goes out on YouTube and it does not go into Discord because of the Mac client for Discord. But the bottom line here on this one, I'll go ahead and play it. It'll probably get tagged for copyright on YouTube, which if you're on YouTube, you can hear
Dilbert. He's not like other kids.
What do you mean? She says I'm worried about little Dilbert.
I left him
not
alone
like
for
other
a minute,
kids.
and he disassembled the TV, our clock, and the stereo.
Yeah, that's perfectly he disassembled normal. The TV, the clock, the stereo.
The part that worries me is he used the components to build a ham radio
Oh, he
set.
used the components to build a ham radio.
Oh, dear.
I'm interpreting for the people on
Is that
Discord.
bad?
You know,
Normally,
is that
I'd
bad?
want to run an EEG on him, but the machine isn't working.
He says, I'd normally run an EEG, but the machine's not working. Of course, Dilbert fixes the machine.
It's worse than I
It's
feared.
worse than I feared.
What is it?
What
I'm
is
afraid
it?
your son has the knack.
I'm afraid your son has the knack.
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical.
Okay, it's a rare condition characterized by all things mechanical, by an aptitude, is that what he said? For all things mechanical or electrical.
And utter social ineptitude.
And to utter social ineptitude.
Can he lead a normal life?
Okay, the mom, Dilbert's mom says, can he lead a normal life? And then the doctor says, no.
He'll be an engineer.
He'll be an engineer. She cries. And he says, there.
Don't blame yourself.
Don't blame yourself. Okay, so that's the live translation for Discord. And for YouTube, they're like, shut up, don't talk over the thing. But I love this, okay? Because I think that, oh yeah, Matthew, I should troll everybody. This is very going to be on the test. Thank you for dropping the link, man. Yeah, that Dilbert's going to be on the test. That whole juke doesn't work because after you've taken it once, you can take it again and you already know now what it is. But no, I love this clip because to me, it's like, look, being an engineer is about whether you were kind of born with it, whether you've always kind of manifested it. You know, some of you are the kids who would tear apart stuff just to see how it worked. Some of you weren't. And it's okay, you know, but ultimately you have to acquire the skill of being an engineer. There, don't blame yourself. Okay, so one of the tricks of the trade is a thing we call stepwise refinement. Also, we can think of it as sort of a systematic decomposition, but we always called it stepwise refinement. All it really means is start with some problem, break it down into composite parts. Okay, decompose it. What are the composite parts? Now that you know that there are like 5 things, like I want to go and build a go-kart. Well, what are the things I need? Some kind of frame, some kind of wheels, some kind of propulsion, some kind of seating, some ability to steer. I mean, you can basically just say, well, there's like 6 things I got to worry about in order to make a go-kart, right? Now you can say, okay, the wheels, well, there's got to be some kind of an axle. It's got to be steerable on the front, or unless I want to steer it in the back like a forklift. It would be a really bad idea if you were going to do what I would have done as, take a go-kart down the street, down a hill. Just saying, right? And then you just say, well, okay, let's talk about the steering mechanism. How's that going to work? Well, some kind of handle, something, doesn't have to be a steering wheel, but some mechanism could be left-right brake type systems. It could be, but somehow I've got to have the ability to steer it. Could be, you're on a bicycle, or unicycle, and there is no wheel, But the point just being that there are a handful of key ideas that are in this system, and you've got to break the thing down, right? If you want to make like a hamburger shop, and you understand how a hamburger works, right? There's a bun, there's beef patties, there's vegetables, and the veggies need to be cold, right? The sauces can be at room temperature. The meat needs to be hot. You've got conflicting pressures around you, right? And you've eventually got to understand how to keep the lettuce and the tomatoes cold, how to keep, how to do this thing, how to make it within certain requirements, like a certain amount of speed. Just saying, that if you study it out, you realize there's a handful of parts to this problem. Just like there's a handful of pieces, to a hamburger, there's a handful of components to the problem of how do I make a hamburger, right? And then I've got other problems like how do I do that in a restaurant with a certain level of efficiency. If anybody's interested in that, I recommend the movie The Founder with Michael Keaton. Basically, it's the story of Ray Kroc the sort of the birth of McDonald's. I know McDonald's has a well-deserved bad rep right now, at least my opinion. But at the time, there was a level of efficiency that was pretty much previously, unattained. Well, how do you get to that point? Well, you start by, it's a design problem. You got to break the thing down, and then eventually you just keep refining it, until you eventually create this amazingly cool solution that looks kind of complex, but you got there step at a time, one little breakdown at a time, etc. Okay, I hope that makes sense. You've got to clearly understand the problem. We call that disambiguation. It just means getting the ambiguity out. Like if the problem is like, I need to make a hamburger. Okay, this is why sometimes sometimes when I'm asking you questions, and this is true, by the way, in all my classes, I've noticed this as a pattern. I'll ask you to, well, tell me what's going on here. What does that instruction do? And you'll say, it adds. Well, yeah, but that's not precisely what it does, right? And I'm trying to get you to disambiguate at every turn in your communication, because that's a critical part of disambiguating the problem itself. So if somebody says, I need you to figure out how to make a hamburger. Okay. Do I have enough information to go after it? To even start, do I have enough information to start? What do you think? Maybe drop some comments.
I know I don't, but I know the internet does.
Yeah, but what's the big missing thing? You've just told me that my problem is I need you to make a hamburger. That's all you said to me.
A hamburger. Oh, I thought you said a ham radio.
Oh, no, not a ham radio. No, but also true. Also true, the internet will help me with all these. But if I said a hamburger, right?
Need materials.
Yeah, but you're too far ahead. You're too far ahead. Back up. I said you say, okay, what do you want me to do? And I say, I want you to make me a hamburger. What are you missing?
Kind of hamburger.
Okay.
Like what?
Before that.
What do you want in or?
Before that. Pull it back. Pull it all the way back.
I want me to make you a hamburger.
What's that, Gomez?
Oh, sorry, I'm just thinking.
Okay.
Would it be the knowledge of how to make a hamburger?
No. I mean, ish. Everybody more or less has some vague notion. But let me just I'll jump in. What type of hamburger radio? Okay, everybody's missing the one key piece of disambiguation. Okay, so far, everybody's missed the biggest piece of missing disambiguation. The epic ambiguity in the problem spec, make a hamburger. I know somebody can nail it. If not, I'm gonna do it in like 5 seconds because we just don't have time. Okay, are you ready? Context. I don't know why you want me to make a hamburger. Does it make a difference? Why? Am I making a restaurant to make it? Am I making a hamburger? Am I making the first of 1,000 burgers today that I'm going to sell to customers? Is that the burger you want me to make? Are we barbecuing on the back deck? Is that the burger you want me to make? Is there some other context that involves certain things that you feed to your dog that you call a hamburger? I don't even know what in the hell you're talking about. I have no clue. I only know, vaguely speaking, bun, beef, veggies, ish, and I cannot start. I don't know enough to start. All right. Texas. I think it does relate to social contract, right? Because when Ray Kroc met the McDonald brothers, and bumped into their restaurant. He was selling a machine to make shakes, and that's how he met the McDonald brothers, right? Okay, he was going around to fast food restaurants, to hamburger restaurants, primarily, right? They had a certain idea about, I mean, it was a restaurant that was making hamburgers. And then there was an entire operation centered around a spec that they had, not unlike Disneyland and some other really, really innovative early innovators like Walt Disney. The McDonald brothers had a spec that they wanted you to be able to come to the counter, pay for your food, and before you stepped away, your order made for you, and again, take it back 50, 60 years, but your order was going to be given to you hot right there before you stepped back away. Okay. So they took the notion of it's a restaurant. So hamburgers for a restaurant. Okay. Now, do I still have enough? If I say restaurant, hamburgers for a restaurant, what's your next question in the stepwise refinement? Talk to me.
What kind of restaurant?
Right. Be more specific.
Hmm.
Ask a more specific question. What kind of restaurant? Chinese. How we doing? It didn't work, did it? Give me a better question. Alex says when a man asks you for a hamburger, you don't question his motives. I'm blowing that out of the water here, aren't I, Alex? I'm saying no, absolutely. You got to understand his motives. And it really is about motive.
Is this for a burger joint? Like burger restaurant, fast food, or
Right. Are you a low end restaurant? Are you a high end restaurant? Is it fast food or is it slow food? Right? Is this a sit down? Are you trying to figure out how to make a burger at Denny's? I don't know who goes to Denny's for burgers, probably some people. Or are you trying to do something that you can do at a drive through? Is this a burger that has to be created in like less than 2 minutes? Right? Or is this a burger that is going to be part of watching the game and grilling, on the back deck, right? Or do you have something even more innovative? And, imagine it'd be amazing and probably a really bad business idea is you make a restaurant where basically you come in. You ever been to those like, what do they call them? Mongolian barbecue, right? You get all your stuff and you jam it all in there. You make this big pile. They put it on the thing. And they throw the sauce. You know what I mean? And then they cook it right in front of you. But you get all the stuff. Then they cook it and then they put it back in the bowl. Delish. Maybe they're doing an innovative restaurant where you come in and you actually cook your own burger. You do your own fixings, special rubs, other stuff, large size, whatever, right? It's a little extra deluxe. So it's slow because you cook it yourself, right? Right, Alex, who's going to be eating the burger? What's the target audience, right? Is this like a kid's meal burger? Is this a burger for a dog? They must have dog burgers somewhere, somehow. There's got to be, right? The point is, you have to understand this person's motive, right? And okay, I want to hear, Matthew, about this. So restaurant where super fancy restaurant with really high quality burgers, right? Is that your high end thing? You're going to wait a little longer. So, okay, you're going to be happy. You came for a high quality burger. You're going to wait 5 extra minutes. It's going to be amazing and delish, right? Okay, do you see what I'm saying? You have to disambiguate it. And a lot of times we just do this thing where they're just like, yeah, we need this database solution. You know about databases? Yeah, I had the database class. Okay, can you build us a database? Yeah. Okay, why don't you just go get the database built? Because nobody understands. If you haven't had, our background, you don't understand. Even, they don't understand themselves how to disambiguate the requirements. You have to do that. You have to ask them questions to disambiguate so that if they're like, I want a database, what are you going to do with the database? What are you storing in it? How fast is the churn? What kind of traffic is hitting it? Do you need to, does it need to be proprietary? Does it need to be a certain kind of solution, that has some specification that's required by some standards body that you have to have? Can it be open source? Are you okay with like MySQL, or could it be like SQL Server, or You know, do you have any other? You've got to understand what all the options are and then guide them with great questions to figure out just what you're going to do. And that's just to even just like pick which database software I'm going to use, right? You're constantly, and that is part of stepwise refinement, okay? But that disambiguation is very hard because users don't know what they want, okay? They don't know. Oh, there you go. There you go. Oh, that's horrible. That's horrible. Then you've got to try to, now that you know kind of what it is you're trying to do, you can start to break the problem down into solvable chunks, okay? And then try to understand, you know, the relative merits of the various ways you can do something. And then eventually you're going to reassemble and put those chunks back together, okay? It's very challenging to do good design, and good programming always has some basis in this process. Break it down, put it back together, okay? Critical, critical, critical. I don't know if this is on a module exam. It doesn't matter. You need this in your life, okay? So here's an example that should resonate at least a little bit with you. We're going to try to bring it back to assembly language, okay? Here's some task that we're just, you know, there's a task. And let's just say that there's things that have to happen a number of times. Well, we got a couple different ways of doing this. Imagine, in this case, I think we're looking at like 2 subtasks. One way we can do it is sequential. We just do the first thing, then the next thing, the next thing. There's 5 things. Do 1, 2, 3, 4, 5, right? That's one way to break the problem down. Another way would be conditional, where I'm going to test this condition, and if the condition's true, I'll do the one subtask. If it's false, I do the other subtask. Or maybe I've got to do it iteratively. Maybe it's 1,000 times. I don't want to write 1,000 times. You know, I don't want to go, if it's the first one, do this. If not, you know, jump around it and then check to see if it's the second one. I don't want to do that forever. Maybe I just need to do it 1,000 times and use iteration for it. See, these are just the ways that we, you know, these are skills we give you, and we look at the problem to try to figure out what's the right way and best way to do that. Okay? So in this case, what we're going to do is look at it from the perspective of the LC3. So we're going to pivot back to assembly language, machine language. Okay? So here we go. We're going to break this thing down. We're going to do all 3 of these. We're going to do the sequential, the conditional, and the iterative. Okay? And by the way, when you get into writing these programs, this module we're in, which is module 7, that module is chapter 6 in the book, but module 7. This module is really about writing more programs. Keep writing programs. You've got to be writing the programs. And this will begin to be second nature as you do that. But sometimes initially you'll be like, you know, I don't know exactly what to do. And then this can be a point of reference. Either look back at the slides, which are on Canvas, or come back to YouTube and just review this lecture, okay? So what does that look like? That's our little kind of design, right? Do the first part and then do the second part. Well, this is what it looks like in the LC3, right? Here's the program counter. Just set it right here and just do all the things. Then do the second thing and you're done. That's it. Sequential stuff is pretty simple. Many things need to be done sequentially, but many things not so much. And you wind up having to iterate or make decisions or branch, right, based upon some condition. So let's take this one. The way this guy works is you hit this testing of the condition. If it's true, you go subtask 1. If it's false, you go subtask 2. And then you kind of like rejoin at the bottom. What's that look like on the LC3? I'm going to show you. So we're going to first do it where the condition's true, okay? So you set the PC, the program counter, to give you that first little bit of condition. And you'll notice that we've done these already. I'm pulling back to give you a little bit of a higher view of what we've already done in machine language. I'm going to generate the condition. Okay, what's the 0000 opcode? Anybody remember? You can also look it up real quick. That hint, it was a control instruction. Other hint, yeah, thanks, Matt. It was a branch. That's a branch instruction. So this little question mark refers to the condition codes, like branch on some condition and where am I going to go, right? So when I get to this test the condition over here, that's this part right here. If it's true, I skip around everything. I branch. I take the branch, drop down here, and I do subtask 1. That's it. I keep going. Now, what if it's false? This is the false condition. Again, I generate the condition. I get to the branch. Only it's false. I don't take the branch. I do the subtask, and then that's still the next one is a branch instruction. 111. I'm saying all 3 condition codes are on. I'm going to take an absolute branch. It's like, it doesn't really matter what just happened. I'm going to jump. And what am I going to do? I'm going to jump around task 1. That's the pattern. That's the pattern for a conditional statement in machine language or assembly language. Okay? Assembly language, same pattern. All right? And what about iteration? With iteration, we generate a condition. We test that condition. If it's true, we do the subtask, and then we go back up to the top again. And then we again check the condition. If it's true, we do it again. As long as the condition holds, it could be, remember we talked about, it could be a counter. I'm going to do it 1,000 times till I get back to 0. Or it could be a sentinel. There's some event or something I'm looking for. When I see it, then I'm done. And if that ever fails, I kick all the way out. Okay, here we go. So there's our little condition generation. Set the program counter. It does all the stuff to set everything up. Then it gets to this branch where it checks to see the condition is whatever we set up. And if that condition is true, we do the subtask, and then we do an absolute jump back up to the top where we, either we go back up here and generate the condition, or we can do some condition generation down here at the bottom and jump right to the test again. You can do that either way. Get the code, check it. Oh, this time it's going to be false, and we just kick all the way around. Okay? So you're basically just jumping until the condition is not met. Then we jump all the way. You got to jump around this absolute branch. Okay? These are patterns. These are little patterns. In 3450, we talk about patterns. These are idiomatic patterns, small little patterns that embody a way of thinking about how to do a for loop, how to do an if statement, and how to just do regular stuff. Okay? This is also this is my flowchart interlude for Hey Jude, which is actually a really amazing song until the very end where I think it gets a little crazy. Or maybe you like that part, but this has a few problems as an actual flowchart, but I still think it's a funny sort of meme, And then I really like this part here, na 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 na. And the problem with that is it's got to go a certain number of nas, right? Na 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 na, 11 nas, and then Hey Jude. See, it's not even accurate. You got to go 11 nas, then you got to go Hey Jude, back to the nas. Just saying, yeah. Oh, and we could definitely do that with a little Rick Astley. We could definitely Rickroll everybody with a slide. No, okay, thank you, Matthew. That's friggin' brilliant. I think I'm going to replace this for the next generation. And then we just got to get him doing that thing, Maybe actually drop the video in. Rickroll the world, baby. Yeah, that's probably going to be better. I'm sure it exists, by the way, if somebody wouldn't mind finding that. Well, that's Rick, but if somebody wouldn't mind dropping a flow chart, that thing right there, that was was that a thing back then? I don't think it was. I was alive and everything, but it feels like that was mostly just Rick. Okay, we've been Rickrolled. Thank you, but can somebody find that actual graph, like a flow chart of Never Gonna Give You Up? That would be fantastic if somebody would do that. Okay, because I can't do that because I got to keep moving. I'm not going to give you up, and I'm going to keep going. So let's take an example, and I'm going to move. Okay, hang on. Okay. Yeah. Okay. Spencer wins the race. Sorry, Matthew. Oh, 6 times. See, we actually go 6 times. That is just a thing of beauty. Okay. I promise, by the way, that I am going to replace this for next semester with that because I just think it's more worthy of our, attention, frankly. Okay. So what we're going to do is right now, and this is really the bulk of what I have to do, what I have remaining, which we may, like I said, we might actually get all the way through these today. But I'm going to say, okay, we got this problem statement. I know it's probably a little hard to read, but it's not so much about let's solve this problem as it is about how do you go about, what's the process of thinking is what I'm really trying to get at. So what I'm going to do, I'm going to input a character. I'm going to scan some file. We did this one earlier, right? Counting how many, occurrences of that character. Then finally, I'm going to display on the monitor the number of occurrences of that character, and I'm going to cap it at 9. Okay? Well, you ought to immediately already begin to see that there are some chunks to this thing. For example, I got to input a character. I got to scan a file and count. What's that feel? Inputting a character feels linear, right? I got to scan a file counting occurrences of that character. That feels like it's probably going to be iteration. I'm going to keep pulling the next line till I get to the end of the file. It's more like iteration with a sentinel because I don't know how big the file is maybe going in, right? And in the middle of that, I've got a conditional. If I find a character that matches my character, I increment the counter. So there's a conditional in there. And then when I'm done, I've got to display on the monitor the number. But you see how already I can begin to stepwise refinement. I can begin to tease this thing apart. Okay. So here we go. I took that first part, input a character. I break it out right here. I've got some initialization, right? Get everything kind of set up. Give me a character. I got to set up a pointer to the first location in the file. This actually, to me, is jumping a little. This comes from the book, but I think this could be done better because I think the first step really is to break up these distinct phases of give me a character, give me a file, let me go looking, and then let me keep counting, and then let me spit it out. That's really the first high-level view of this whole thing. But I do kind of set this thing up, but I don't like set up the pointer. To me, I need to be like, give me a character, set up the pointer, give me a character, scan the file, well, sorry. This is really almost all just about inputting a character. All this stuff right here. And kind of plus some initialization. But I do think it's a little bit too detailed, too fast for the actual process by which you think it through, my opinion. This next part is scanning the file. But see, to me, this is like kind of high level, and this jumps a little too low level for my taste. I need to change that. Walter, Zach, make me change that. Was Walter in? Yeah. Walter, make me change that, okay? In the mythical future when all things are possible, make me change that. B is like scan the file location by location, increment if the character matches. That's good. And then I got a lot of words here. Half the text over here is the shortest box over here. Display the count. Okay, so that's my kind of, sequential decomposition. Here we are over here. Now what am I going to do? I'm going to take this guy and I'm going to add a lot more specifics. Like, well, I've got a counter. We'll call it R2. Let's clear that out. I got to get me some keyboard input, which we haven't talked about how to do that yet. That involves a trap instruction. I got to get the address of the first character in the file. And then I've got to actually grab that character. So there's some setup I've got to do. Okay, that's cool. Now this part here, let's refine that a little bit. I got to scan the file, one spot at a time. Well, I have a character in R1, and what I'm really asking is, am I done? And I'm done, and this, by the way, is not great. This doesn't really build in the max of 9. I'm sure just for simplicity. But it's like, am I done? Yes or no? Yeah, I kick out. If no, then I'll check the character. Like being done means I hit the end of the file or I hit 9. Those are my two conditions where I'm kicking out. So I'm going to test the character. If I get a match, then I'm going to increment the counter. And then I'm going to get the next character so I can jump right back here to check to see if I'm done again. And then what we're going to do now is take that, notice we take that red box right here on the right, and let's just kind of, put a box around that because it's kind of one thing. This one we actually break up a little more. What I don't like about this kind of stepwise refinement is that to me it's it's coming in too unevenly. You know what I mean? We're basically right down to machine code here, and here we're still just thinking about the logic. But again, there's different ways of doing this. You can take one chunk and take it all the way deep till it's cooked, then do the next one. You can take all of them and then like refine it a little more, refine it a little more. You really can do it different ways. There's nothing magic about one way over another. This is one where, what was the deal here? Oh, we split up the fact that we had test the character, if it's a match, increment, and then get the next character. We broke out the part where you get the next character because it really is a separate idea. The displaying is like prepare to display and then go ahead and display. We're just refining it. Now we're going to go like, well, we do have that conditional right here, right? Test the character if there's a match. So what do? We've got the character, which is, we've got the, R0 is the value of the character we're trying to match. That was the input. R1 is the most recent character we pulled out of the file. We just want to look at those two and see if they're the same. If they are, that's a yeah. And we increment R2. And then we get the next character and we jumpy, jumpy, jump. If it's no, we just also get the next character and jumpy, jump. But we don't increment R2 because it wasn't a match. So you see how we did that? Took this little idea over here, blow it up over here, and then get the next character. We're actually like, what we really need to do is also we got R3, which is our starting address in the file. We got to increment that every time, so it's actually looking at every location in the file. All right, and this is the point. Do I have, no, this right here. If I just didn't show you the thing on the left and just showed you the thing on the right, your first reaction is going to be like, oh, your eyes are going to fuzz over. You're going to be like, okay, wait, and it's like, okay, I got a couple of different triangle or what are those diamonds? I got lines, I got arrows, I got branching back, right? And all that thing on the right is the little problem statement on the left. That's it. So when you get to like the homework and the module exam for module 7, it's really just gonna be this. It's just more exercise at those programming skills when you're thinking at a very low level. That's all it's trying to do. You're just going to write some programs like take a number, read a number from this location, read a number from that location, multiply those two numbers together and spit the output out to the monitor or something like that. And then what you're going to have to do is look at that and understand how to break this thing out, how to break it down, how to refine it, how to turn that into a design, then code that. Then you're going to actually write that in machine code. Another problem is you're going to look at machine code and I'm going to ask you, what's it do? Okay. It's just the same exercise going in the other direction. All right. Literally, that is the heart and soul, plus the whatever the fear of God speech was that I did last time. That's the heart and soul of module 7. It's all we're trying to do is give you the experience to refine your programming at a really low level. Okay? That's seriously it. I want to talk about debugging for just a little bit, and then we're going to be done with this module. Amazing, right? Like basically one day plus a good speech last time, and we're out. And how we doing on time? Oh man, we got all kinds of time. All right. Debugging is notorious. Oh, thank you, by the way, for the Rick Astley presidential sign. I did strongly consider. I know of this, and I was strongly considering just making my own yard sign last go around because that was the level of sort of political despair I had been plunged into by everything. Kind of an aggregate weariness, you know what I mean, with everything. So Rick Astley will never give us up or let us down. Okay, I want to talk about debugging. Now, here's the thing. Debugging is the process whereby you determine that your system, whatever it is, it could be your car, could be your laptop, could be your lights in your bedroom, could be anything. The worst thing it could be is in the code you wrote, because then it's your responsibility to figure it out. Now, the good news about that is, if it is your code, then you also can go change it. So that's good. But this skill of debugging, how do you? Again, it really relates. I'm not going to redo the speech again, but it relates to the question of like, I don't even know how to start. It's that little kid with the poopy diaper thing. Your stuff doesn't work. What are you going to do? And nothing is really not a great option. Not if it's like a classroom assignment or a professional assignment. It's really not a good idea on a professional assignment, right? What are you going to do? And when it doesn't do what you need it to do. Now, there's one issue which is really testing, which is how do you even determine that it doesn't do what you're going to do? You know what I mean? That's by itself already a thing. And it's really important somewhere in this undergrad experience to acquire some experience doing testing, and if you get really good at it, and I spent a few years focused in software testing, right, in some very innovative environments at the time. It was the early 90s, but we were doing some of the stuff that was actually cutting edge in the world at that time. It was a long time ago, but it was still networked stuff, but it wasn't, there was no web to speak of, and a lot of things had not happened. But when you have spent as much time as I spent in a professional software testing environment, the biggest thing about software testing is that your job is destructive. When you're a developer, your job is constructive. Yeah. Thank you, Gabe. We all need to learn to clean our own poop. This is exactly the point. Figure it out. You have to figure it out. I'm sorry. That's the deal. You have to figure it out. You know? I know what some of you are thinking. Heartless bastard. Yeah, maybe, but that's the deal. That's the job. That is the job. It's what you got to do. There's nobody going to pay you to make software that doesn't work. So testing is destructive. Your goal is to make it break. And software development is constructive. Your job is to make it stand. So, developers are building these great towers, and structures, and testers are like angry birds, they're just kind of flinging their stuff at the structures and just trying to break them. And the idea is, when you're a software tester, if you break their software, you're not the bad guy. Their software is bad. You broke it. You broke it. You bought it. You break their software that the developers were building, then the customer doesn't have to, right? You need to figure out how to break it while it's in-house before it rolls out to the customer. Okay. Now, debugging is this thing that happens, and we're not really going to dive deep into software testing. It's another topic. I know you get it in some classes that I don't know what they are, but it's a huge and important topic. Debugging is the process whereby you detect somehow. Maybe you found out because of systematic testing, you discovered that something was broken, or maybe you just noticed that it broke. But ultimately, there's one term I want you to know, which is test case. A test case. When I'm testing, you're going to do this project at the end of the semester, and when we're testing those projects, there are certain test cases, right? For example, it's going to ask you to input strings from the user, and the strings are supposed to be, the names of LC3 instructions: add, not, and, right? BR, JMP, right? Well, but if somebody types J, that's invalid. If they type JM and then enter, not valid. JMP, yes. JMPY, jumpy, no. Rando character like an ampersand, no, not even a valid character. Punctuation, pluses, minuses, that's not actually punctuation. That's equations, periods, commas, apostrophes, right? No, they're not valid. There are these limits and requirements, and they determine what's valid and what's not valid. So there are ways to sort of think about, what are the inputs I'm going to try that are valid, and what are the inputs that I'm going to try that are invalid inputs. So there's a whole thing to doing systematic software testing, even at a very small level like your little programs. But debugging kind of just goes, I know I've got a problem. Why does it act like that? Where is that really in the code? Okay. Alrighty, rock and roll. So, all right. Number one, throwing up your hands, not an option, not a strategy. It's an option, but it's not a strategy for success. The primary task, understand that the primary thing you're doing is learning. Okay? If you actually knew everything about this thing, there wouldn't be a bug, would there? If there's a bug, there's something you don't know. Well, you better go figure out what that is. You got to learn that. Okay? Now, there's a speech that I give in other classes called The Orders of Ignorance. And I'm not using ignorance in a pejorative sense. Okay? It's not meant to be a negative. Ignorance simply means lack of knowledge about certain things. I don't mean willful ignorance or, I don't know. There's a lot of negative connotations. I'm using it in the sense of failure to know a certain thing. Am I ignorant of how to conjugate verbs in Romanian? Why, yes. Yes, I am. I am ignorant about that thing. What I've got to do is strategize about knowledge acquisition, right? What do I not know right now that if I knew it? Now, here's one of the things that's classic. Okay, number one, it is better to take the time to fully understand than to just kind of randomly change code and hope it works. There was one time in my undergrad career that I stayed up 3 straight days working on, it was an assembly language class, okay? And some of you, if you're in or have had, I don't even know which class it shows up in, maybe 1420, 2410, 2420, I don't remember the numbers. But after 1400, there's a class where you learn about linked lists, right? What class do you get linked lists for the first time? Anyway, we were implementing linked lists in assembly language. So that's also part of why when I was, when I was in your shoes, it was worse, uphill both ways, barefoot in the snow. You got the idea. But I did, in my first assembly class, implement a linked list, doubly linked list in assembly language. I learned a lot, but man, it was brutal. Okay. Oh, Dunning-Kruger. Yeah, there we go. There we go. Oh, what do we got? Do we have knowledge, experience, know nothing, and guru? The peak of Mount Stupid. Yes, yes. Yeah, thank you, Matthew. I like the Dunning-Kruger effect, which some have asserted has been proven to be not empirically true. But I think that there are principles that are embodied in it that I believe to be true. Okay, 3 days working on this program. And I didn't sleep for 3 days. Now, in retrospect, what I should have done was stopped everything. Slept, gotten up, had a nice breakfast, something that I really like, gone to a movie, gone on a hike, spent 24 hours enraptured in personal pleasure and satisfaction. And then on the morning of day 3, just stop and understand the program actually really, really deeply. Really understand what I'm doing instead of just chasing my tail, because that's actually eventually what I did. Minus the hike, minus the matinee, and probably minus the really great breakfast. I just slept, took a shower, and said, okay, I'm dead in the water anyway. I'm just going to start from the beginning and really understand what's going on here. And in about an hour, I understood what it was I was actually trying to do. And in another 15 minutes, I had fixed my code after 3 days of chasing my tail, doing the weird push me, pull me, like, maybe this is it, maybe this is it, maybe this is it. Living in that land of guesswork, very bad. Okay? It's not a strategy for success. Okay. So there are a lot of situations in which debugging can be the most consuming part. Now, I would argue that if you're doing it really, really well, and this is again something that being in software testing really taught me, what I actually learned to do, and this is again relates to design and development, but it's a strategy I learned in a destructive job like software testing. But it is, I look at my code, I do the basic core thing. I do that one thing. And then I show myself definitively that it works. Okay? So, for example, on this program we were just designing, what I would do is I would go, what's the very first thing I've got to do? Well, I've got to get a character out of the keyboard. Okay, let me just do that. And you'll learn from the spec that when you do this trap instruction that gets a character from the keyboard, that it puts that character into R0, and that R0 contains an ASCII value. That's all about social contract. That's just how it works. So I'm going to write some code, do the thing, and then I'm going to step through it in the LC3 simulator, which I'm going to show you before too long. I'm going to step through it in the simulator, and I'm going to then look and see in R0 that there's a value in there, and I'm going to look it up in the ASCII table, and it's going to be the character I typed. And then I know that I got to here, okay, and no other registers got trashed, if that's important or whatever. Okay, I know it. Now what's the next thing I'm going to do? I'm going to do that thing, and then I'm going to test it, and I will know it. So that every part you get, you know. Next part, you know. So everything you've done, you're operating in knowledge. The alternative is what we sometimes call the Big Bang. I call it the Big Bang approach to testing. You write your whole program out over in a piece of paper. Then you type it. This is the 60s. Stop it. That's the 60s. Then you have interactive tools. 60s, you had to write the whole thing and submit it as a batch, wait 3 hours to find out if it ran. Okay? On Hollerith punch cards, which I did in the 70s, not the 60s. I mean, I was a precocious child, but let's not be ridiculous. Okay, you with me here? With the Big Bang, I just type it all, and then I run it, and it breaks. The odds of doing that and having it run are about 100 to 1 against, maybe 1,000 to 1 against. It can happen. It's not a strategy for success. Okay? Because what's the problem? If you've got 500 assembly instructions and the thing starts you're in guesswork land. You're in guesswork land. You don't know, like, where did it break? What? Right? So if I take here, right here, Big Bang approach. Do I have a picture? No, I don't have a picture. But, it's like you put this airplane together, you send it off the runway, boom, it explodes, right? And now you got to go sift through all the wreckage to figure out what happened. Now, the one advantage you have with programs is that you do have the ability to go back to the beginning and walk through it in the simulator. First instruction. But that's what you should have done when you first added that instruction. So you just knew. And if I'm going to write a program that does a bunch of stuff, like let's just say it's got to do this thing 1,000 times, I'll put a little print statement in the middle that just goes, here I am, and then put like the value of the loop variable. Because a lot of times you'd be like, I set my thing to be at 0 and it doesn't stop, and it goes one too many. Supposed to do 10 times, it does 11. Well, what you have to ask yourself, what do you not know right now? Okay. One of the things you don't know is like, what's the actual value of the variable? So every time in the loop, spit out, I'm in the loop, and here's the variable. Like I is now 10. And you look at it and it runs 11 times, and you realize, oh, I did the one thing here instead of there, right? Because I didn't move on until I knew that was working. I'll even do whole structures with classes and objects and write the whole thing where the objects spin up. They're just dummy constructors, sets it all up. And then I just start invoking stuff. I have a little driver that just goes, hey, do this, do this. And then what happens pops out on my screen. Got here, got here, got here, got here. And I have a test script that knows that my structure works. Now I can like fill this one out, fill that one out, and do it structurally, do it systematically. Okay? My brother was helping someone with their code. The first thing that he suggested to try fixed it. He was very incredulous to know why it actually worked first try. Well, you get lucky sometimes. You get lucky, or your best guess isn't bad. I mean, that does happen, right? But the problem is that if you're operating in a domain of not knowing, of really operating in a domain of ignorance, what other bugs are in the code that you just didn't see yet because your test cases were inadequate, right? For example, when you write your code, if I type 1,000 characters, is your code going to break? I'm not going to do that, but I'm just saying. Right? So this is really key. This second bullet here, if you don't know precisely what's going on, in other words, it not only has to work, you got to know why it works. This is generally true, because if you don't know why it works, then it can just randomly self-break later, And especially if it self-fixes. If it self-heals, I guarantee it's coming back with a vengeance later when it self-breaks again. Because there's something you changed that just caused it to not manifest. And when that changes again, it's going to come back. Okay? But when you don't know exactly what's going on, the time required to finish is unbounded. It's infinite until you know. That's why the knowledge acquisition is the key thing to know exactly what it's doing. And the best way to do it is to know it as you add it. Add it, know it. It's going to take you a little longer, but you are never going to be thrashing through your code not knowing why it doesn't work. Okay? This is, my friends, this is central. This is not on an exam. It should be. Maybe it should be. Walter, let's think about that. But this is so central to your whole undergrad experience and your whole career after that. You get good at this, it is so incredibly valuable. Okay. Another thing, by the way, I don't know if it's on my next slide here. Yeah, let me go. Let me see. Yeah, I just want to say this. Whenever this comes in part from, raising kids. Whenever one of my kids, when I'd be like, they'd be like, I can't find my shoes, right? And then I would usually go, okay. And I like maybe head into their room, right? Start heading into their room. And they're like, I already looked here. And I'm like, you, my young little friend, have no credibility whatsoever. And you know, you can never find your shoes. Every single day of your young little life, you can't find your shoes. Every day of your life, you fail to find your shoes. And you think I'm going to be like, oh, well, uh, she already looked in the room, so I know that they're not there. You know what I mean? I mean, like, no, you have no credibility. So when someone comes to me and they're like, I can't figure out my code, and they're like, I know it's not over here, I'm going to immediately place a $5 bet that that's exactly where it is, because they don't know where it is. They don't possess the skills required to narrow it and to actually find it, but they express a confidence of where it isn't. These are inconsistent positions. Okay? That's all I'm saying. So, it's that whole idea. It's just that whole idea. Okay. So you have to know where your program is correct. And then the exact moment when it goes off the rails and doesn't do what you needed it to do. So you have to know, after this instruction, this is what's going to happen. Here's what's going to happen to the control codes. Here's what's happening to the registers. You have to know that. When you do know that, you can then just like go, okay, step, yep, that register did exactly what it was supposed to do with that instruction. Yep, the control codes are just perfect. Here comes my branch instruction. I know that right now it should take the branch. Step, yep, it took the branch. Okay, you've got to know, like at that moment, you're like, wait, it didn't take the branch, it dropped in. Wait a second, right? Now you realize that you didn't understand something about the branch instruction. Some of you will submit programs that you have an opportunity to actually run in the simulator. And they'll do things like use an LEA instead of an LDR or something. A, it's open book. You can go look that stuff up. But B, you can know, right? Let's say you're loading a register with someplace, right? You can do the instruction and then look and see what the register is and be like, yep. If you do an LEA, what should show up there is the address of the thing you were looking at. Yep, that's the address. If you're expecting to put a value, into that register, you can look and see if the value's there. You don't need to let it run until the whole thing just kind of crashes. Okay? Does that make sense? You've got to know. No, don't operate in the guesswork zone. Dallin, I read a story about someone who wrote some low-level code, ran into a bug, and determined the process was wrong. Yeah, no, that actually happened on a dev team that I ran in Oregon. We would do we did the infrared beaming in the Palm Pilot. Remember, you're too young, but if you remember the legends in days of old when knights were bold, that you could transfer objects between Palm devices. My company in Oregon actually built that software for Palm in the late 90s. I think it was the Palm 2 was the first one that had it, the Palm Pilot. But we were dealing with new boards that came from all the major, the manufacturers of the embedded boards. Motorola was the big one at the time. Yeah. And we absolutely found bugs in the processors because we were super early customers to the whole thing. And well, how do you do? You're going to kick this back to Philips or back to Motorola or back to whoever. You can't just be like, wham, I can't get it to work, right? You need to basically be able to be like, okay, let me, you got to really, really know what you're doing and get down to it and be like, and you have to know, like, if the board is correct and I do this, it should do that. I do this, it doesn't do that. Why? You know what I mean? Here's another one, actually. This is a true war story from my childhood when I was in my late 20s. I was at HP and we had a 4-function controller card back in the days of the early. We were working on HP's. You sparked all this, Dallin, so I hope you're happy. But we had this 4-function controller card, which like serial, parallel, serial port, parallel port. I don't even remember. But basically remember the old parallel, maybe you don't, COM ports, RS-232, blah, blah, blah. But there was a board you could push into that bus on the original IBM PC type architecture, and I was working on HP's original personal computer, and I was doing operating system stuff in assembly language for OS2, device drivers for OS2 on the original Vectra Classic, as we called it. And there was a bug in the controller card where about once every 20, you'd print characters to the printer, and about 1 out of every 20 characters wouldn't show up. Just be gone. Just here comes letters. Everything's correct. A letter's just missing, and it just keeps going. It doesn't know it. What do? And you're, 6 months out of college. That was me. And me and my good buddy, Jens, we just kind of dove into it. My recollection is that Jens was the brains of that operation, but we basically eventually just decided we needed to look at the actual inputs and outputs on the board. So we got an oscilloscope, which apparently we could get our hands on relatively easily, strap the oscilloscope up so we could actually see the values, like we could see the values of the bits coming in to the board from the PC and then kind of like making its way. And we basically figured out that there was an inverter, right? A NOT gate. There was literally what they call it an inverter, but there was a NOT gate. And there was a NOT gate where there shouldn't have been one. And they had basically copied a design from IBM on a 4-function controller card that had that in there, and it was flawed there. They basically copied the design and it was flawed here. So we literally took this AND gate. You could see the NAND gate. You could see the inverter as a little chip with wires coming out, little chip, wires going back in. Okay. So we take one of these 4-function controller cards and we snip out with clippers, with wire cutters. We snip out the inverter. We attach alligator clips to either side of the wire with the wire between, so that it ran as if there was no inverter, right? and it's all like put the board back in with the alligator clips, and then launch the next print job. Worked perfectly. No lost bytes, no lost characters. And we were like heroes of the day, right? So we go rolling back to management. We're like, oh yeah, you know, it's the card. The card's got a problem. Blah blah blah. And then we're like, so we're done here. Our work here, our work here is done. And then management was like, all right, cool. Wow, congrats. That's great that you figured that out. So fix it in software. Fix it in software. We're like, no, you got to rev the design on this board. They're like, there are like 40,000 of these boards out in the world. Fix it in software. So we had to basically figure out how to detect a lost interrupt going to the board in software, and then basically spin on that until we knew we were good, then send the next character. And then we did it. So we in our device drivers, we basically, fixed it in software. Again, my honest recollection is that Jens was the brains of the operation, but we were rocking it pretty well. Okay, so there we go, down. So that's another example, right? Let me see. Matthew said one time, Matthew made some code. I don't ever say you wrote some code. When I first read that without my glasses, as I made some cookies. I'm probably hungry. I was absolutely sure that everything was written correctly. Had checked every line of code, brought it to the teacher, looked at it, immediately said that I was dividing by 0 in my for loop. Test case. I had a situation once when I was at Novell, and I'm going to wrap up here. There was a guy that I was working with. I shall not name him, but he was just notorious for, here, can you take a look at this? So I'd come out of testing, and I'd look at it and I would break it, and I would look at it and I would break it, every time. And eventually I'm just like, dude, you got to do your own unit testing, man. You can't be like, when I can't break it in 5 minutes, you think you're done. You've got to do your own unit testing on this thing. Yeah, okay. So finally he goes away, and this time it's a longer period of time, and he comes to me, and he has like floppy or whatever. That was back in the days or whatever, or maybe I pulled it off a server. I don't know. But this is the early 90s. Anyway, and I'm just like, did you unit test it? Not even gonna look at this if you didn't unit test it. Yeah, I unit tested it. Okay, I load the thing, I install it. He just kind of looks at me, and I swear it was one of those things where you really understand what the software is doing. You're kind of down in the guts of what the thing is. I literally looked away, and on my keyboard, I made eye contact. And without looking at my keyboard, I went tap, tap, enter, and it went schwang. And there was a thing with Novell file servers called an abend. It's like a blue screen of death, right? But it's called an abend for like abnormal end. And a NetWare file server would do this like, and the whole thing was dead. But I literally was just like, tap, tap, enter, and it goes, bring. And he's just like, how did you freaking do that? I'm like, go unit test this. Take it. Go get out of my cube. Go unit test this. Because he didn't know. All right. Unit testing, good. Debugging tools are about acquiring knowledge about the internals of what you're doing. Now, I'm going to actually not do all this other stuff. So this is the last slide of this module, okay? Strategies. Look at this slide to help you when you're in debugging mode. Initialize variables with known values, then step through. In debugger or even on paper, you can play computer, but you got to know where it's executed, check the values at certain points. You've got to understand, okay? That's really, really the bottom line. And what I think we should do, I'm thinking maybe this weekend, if I can get some time, I'd like to do a help section on the LC3 and kind of introduce that, just to kind of help you bootstrap and get yourself launched into using the LC3. Okay, even in machine code, you can use the LC3. Okay, and I just don't know when I'm going to have the window because I need to go off hours Could be Thursday night after my COVID shot. Friday, I don't know. Could be Friday, could be Saturday, could be Sunday, but somewhere in there. Let me know if you have an opinion or preference. Let me know in the comments. And we're over time. We're out of time, and we gotta cut loose. But that's module 7. Oh yeah, fast and furious modularization. And that's it. We're done. We're gonna kick into module 8 next time.